In 8.2, we're going to be learning the fourth method of solving quadratic equations, and this one's the quadratic formula. So the quadratic formula is foolproof. You can use it anytime to solve any quadratic equation that's in standard form. So the question is, why would you learn anything else? It's because sometimes this one can be a little bit more complicated to simplify in a way, and also a little bit more laborious to do and places to make mistakes. So just so you guys know, the quadratic formula is actually completing the square, which is actually solving by the square root method. So they all kind of tie in together. So to prove that to you, the textbook goes through this, but I also have just sort of a copy of it here. But this is how they've done it. So they've taken this equation in standard form with the a, the b, the c, which is your coefficients, and they've completed the square. So the first thing they had to do was a little bit different than what we do, is they take the coefficient off everything before they complete the square. So this whole process here is just completing the square. Take half the middle term squared, put it on both sides, or subtract and move it over, and then you've got this perfect square, and then you take the square root plus minus, and then you're just isolating x. But what happens is you end up with this equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. And mathematicians have done all the completing square work for you so that you can simply plug in the coefficients on x squared, x, and your constant, and find the solutions of your problem. So let's look at how this works. So I've got four scenarios here, pretty much worked out for you, because I find that people don't make mistakes in plugging in the values. So for example, if you look at this one, we've got ax squared minus or plus bx plus c is equal to 0. It's in standard form. So to be able to use the quadratic formula, you have to be in standard form. A is the coefficient on the x squared term, b is the coefficient on the x term, and c is your constant. And then what we do is we plug it into that formula. Negative b plus or minus b squared minus 4 times the a times the c, all divided by 2a. And people are really good at that, right? Plug in the numbers. Next step is to simplify. So when you take negative b, it means whatever the sign is on b gets switched. So this is now positive 7 plus or minus. Now here's where people mess up, surprisingly enough. It's this part here, this b squared minus 4ac. People have a really hard time plugging this into their calculator. So I want you all to have your calculator in front of you and to be plugging this in. So if I was plugging it in, I'm going to type in negative 7 squared, or maybe you already know that's 49, so you could skip that step in your calculator. Or maybe you don't have to involve the negative because you know that when you square, it's always going to come out positive. But here's the next part. You're going to subtract 4 times 6 times negative 3. Now, this should give you 121. No problem. Okay, so try the next one on your own. Plug this one into your calculator. Negative 4 squared minus 4 times 1 times negative 8. So I'm going to do it too. So negative 4 squared minus 4 times 1 times negative 8, and that one gives me 48. If you're doing it right, let's keep going to the next two. So this one, again, we've plugged in a, b, and c, we've plugged it in, and I want you to plug in b squared minus 4ac. Negative 12 squared minus 4 times 9 times 4, and you get 0. And then this last one, negative 4 squared minus 4 times 1 times 6, and you should get negative 8. So this value here is really important, and it's going to be given a special name called the discriminant, because it's going to help you to determine the nature of the solutions we get. So let's go back to the beginning. Again, to use the quadratic formula, all you need to do is figure out the coefficient on the x squared term, the coefficient on the x term, and the constant, and then plug it into your formula. Negative b plus or minus b squared minus 4 times a times c, all divided by 2a. And then we get these answers. Okay, so what are we going to do with these answers? Well, let's look at the different scenarios we get here. Here we have this number 121 under the square root sign. Hopefully you're recognizing your perfect squares, and you recognize that 121, the square root of 121 is 11. So this would be 7 plus or minus 11 all divided by 12. To find your solutions, there's two of them. There is 7 plus 11 divided by 12, and there's 7 minus 11 divided by 12. To simplify, we just do 7 plus 11 is 18 over 12, and then you always want to give simplified answers, so 6 goes into both 18 and 2, so we'd be left with 3 halves. That doesn't look much like a 2. There we go. This one we go 7 minus 11 is negative 4 over 12, which would be negative 1/3. Now these are exact solutions. If you look back up at the question, it says state the exact solution as well as to the nearest tenth if necessary. So you can do that with these. I mean, these ones I would just leave as these exact solutions, but let's say this one's 1.5 and this one is negative 0.3. So these are your two solutions for this quadratic equation. This parabola had two real x-intercepts. Let's go on to the next one. When you plugged into your formula, again, the only trick I did with this one is that it was x squared minus 4x equals 8. So to be able to plug into the quadratic formula, you have to bring the 8 over to the other side and make it equal to 0 first. So you get x squared minus 4x minus 8 equals 0, so that your a is 1, your b is negative 4, and your c is negative 8. That's really important. In order to be able to pull off the coefficient, it has to be equal to 0. And then we plugged it into the formula. We plugged in that b squared minus 4ac, and we got 48. Now 48 is not a perfect square, but 48 can be simplified. So the highest perfect square that goes into 48, I'm going to simplify it over here so I don't have to keep rewriting my question over and over. The highest perfect square that goes into 48 is 16, and it's 16 times 3. So the square root of 16 is 4 root 3. So the simplified version of this radical would be 4 root 3 all over 2. Now, this is an exact solution. It's getting towards being simplified, but it's not fully simplified yet. And it's not fully simplified yet because out of the top, I could greatest common factor out at 2. And then divided by 2, I can simplify the 2's, and my answer would be 2 plus or minus 2 root 3. Or you could have said this is 4 divided by 2 plus or minus 4 root 3 divided by 2, which would give you 2 plus or minus 2 root 3. However you get to that answer, it doesn't matter. You've got those two skills. You've got the factoring simplification that we did in chapter 6, and then we just simplified using the division way back in chapter 4. Okay, so this is my answer. These are my exact simplified solutions, but it also said to give the answer to the nearest tenth. Now, if they didn't ask you to simplify or give exact solutions, if they just wanted your answers to the nearest tenth, I highly recommend plugging this into your calculator. I would plug in, I'm going to get rid of that equal sign, to find the nearest tenth. I find it easier if you don't have to go through the simplification steps. Right? So only if this doesn't ask you for exact solutions, if it only asks you to the nearest tenth, you can plug in 4 plus root 48 divided by 2, and you could plug in 4 minus root 48 divided by 2, because then you don't have to worry about making mistakes with the simplification. So if we plug this into our calculator, we've got 4 plus the square root of 48, have to hit equals or use brackets around your numerator, and now divided by 2. To this nearest tenth, we get 5.5 as an answer. If we plug in the next one, we go 4 minus the square root of, hitting wrong buttons, 4 minus the square root of 48, hit equals or make sure your numerator's in brackets, and then divided by 2, you get negative 1.5. Now we'd get the same answers if we plugged in 2 plus 2 times root 3 and 2 minus 2 times 2 minus 2 times root 3, we'd get these same two answers. So it's a good way of checking to see if your simplification was correct. But again, I just don't recommend simplifying if it only asks you to the nearest tenth, because you could make a mistake here. But saying that, it's a good way of checking. Plug this into your calculator, plug this into your calculator. This is just the simplified version. It should give you the same value. Okay, but you'll notice for both of these, we got two solutions. We got two real x-intercepts. Even though they're decimals, okay, they are two solutions for the x-intercepts. Let's go on to the next two. Excuse me. This first one, again, just a trick. If it's not written in standard form, you can't pull off a, b, and c. So I moved everything to the left. So we get 9x squared minus 12x plus 4 equals 0. The a is 9, the b is negative 12, and the c is 4. Plugging this in for the values of a, b, and c, and then we did the whole simplification. And we ended up with the square root of 0, which means I'm adding and subtracting nothing. So for this one, x equals 12 over 8, which 6 goes into both 12 and 8, and I would end up with 2/3 to the nearest 1/10 would be decimal 7. So this one, I got one solution. Why? Well, because I was adding and subtracting 0. Right? I had nothing to add, I had nothing to take away, so I only got one solution. So in the first two, I had something to add and subtract, so I got 2 solutions. This one I had nothing to add and subtract, so I got 1 solution. This last one, when you look at it, I've got 4 plus or minus the square root of negative 8 all divided by 2. Now we're not going to do a lot of these in Math 50. We do a lot more of these in Math 60 because this, when you plug it into your calculator gives you error. The square root of negative 8 is an imaginary number. It doesn't exist. So for Math 50 level, we're just going to say no solution. Right? In Math 60, you'll learn that this actually gets written with an I and it's this whole long thing, but we'll save that surprise for Math 60. Okay? But for us, I want you to notice that there is no solution, either empty set brackets or the null sign. And so when this number underneath the square root came out negative, we had no solutions. Now, why do you think I'm drawing attention to this? Well, because that part underneath the square root sign, this b squared minus 4ac, is what determines the nature of your solutions, whether you get 2, 1, or none. So the first part up here, okay, it's just a little bit about that. If b squared minus 4ac is greater than 0, which is both these cases, then you get 2 solutions. Now, just to be extra special, if it's a perfect square, you get 2 rational solutions. 2 rational solutions, and if it's not a perfect square, you get 2 irrational solutions. But all I really care about is the fact that you get 2 solutions. Okay, but it is interesting to know that if b squared minus 4ac comes out as a perfect square, it means that your question was probably factorable and you didn't have to use the quadratic formula, whereas if it's not a perfect square, then you had to use the quadratic formula or completing the square. If b squared minus 4ac comes out as 0, again, you have nothing to add and subtract, so there's only one solution. And then lastly, b squared minus 4ac, oh, and it's rational, sorry. And if b squared minus 4ac is less than 0, you get no solutions. Now, I'm going to say no solutions just to be simple, right? So 2 solutions if it's positive, 1 solution if it's 0, no solutions if it's negative. When you take different courses or if you read different textbooks, sometimes they'll say there's every single one of them has 2 solutions. The first one has 2 real, the second one has 2 that are identical, and the last one has 2 imaginary solutions. But this is Math 50, and I think it's enough to know that if it's positive, you have something to add or subtract. There's 2 solutions. If it's 0, you have nothing to add and subtract, so you get 1 solution. And if it's negative, you can't add or subtract an imaginary number, so you get no solutions. So just quickly, let's determine. So the question in your quizzes or your tests will often say determine the number and type of solutions for the following. Oftentimes it'll say without solving, or it'll say using the discriminant, determine the number and type of solutions for the following. So all you're doing is figuring out that b squared minus 4ac, that part that's under the square root sign. So let's practice a, b, c. So this is written in standard form. It's equal to 0. So the a is 1, the b is 7, and the c is negative 15. So we're going to plug in b, 7 squared minus 4 times a times negative 15, which is c. Plugging this into your calculator, you get 109. Since this is greater than 0, you know that you have 2. If you want to know exactly, it's 2 irrational solutions because it's not a perfect square. But again, it's really important that you understand that it's just 2 solutions. Let's try the next one. A is 3, again, it's in standard form. B is negative 5, C is 7. So if I was to do b squared minus 4ac, the b is negative 5, the A is 3, and the C is 7. Plugging this into your calculator, you get negative 59. Since that's less than 0, that means they're imaginary solutions, which means that we have no solutions. Sometimes they'll specify it's no real solutions, but really it's no solutions, which is enough. Okay, and last one, we've got A is 9, B is negative 12, and C is 4. Again, plugging into B squared minus 4AC, you end up with negative 12 squared minus 4 times 9 times 4, and if you plug this into calculator, you get 0. Since it's equal to 0, there's nothing to add and subtract, so we get one solution. Being a bit more picky, it's one rational solution. Awesome. This would be no real solutions if we're being picky, but again, as long as you understand two solutions, one solution, or no solutions, then I'm happy. All right, tying that all together, all I want you to do is practice plugging into the quadratic formula. So I've got two questions here. I'd like you to try them on your own. So I'd like you to pause the video and then unpause and see if you get the same work or the same solution as me. Or don't pause the video and you can keep watching. So this is in standard form. We've got A is 3, we've got B is 2, and we've got C is negative 8. I highly, highly, highly recommend writing out your literal formula first. Get used to it. X equals negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. And then we're just going to plug in. So in for the B, negative, we're going to put in for the B a 2. In for this B, we're going to put in our 2. In for the A, we're going to put a 3. In for the C, we're going to put a negative 8. And then in for this A, we're going to put a 3. So sometimes I'll start by literally just replacing the letters with brackets, and then you're plugging into the bracket. So simplifying, we get negative 2 plus or minus. Then I recommend plugging this into your calculator. So 2 squared minus 4 times 3 times negative 8, and you get 100. If you find yourself making mistakes with this, trust the calculator less. Put 4, look at the fact that it's two negative signs, so put plus, and then do 4 plus 4 times 3 times 8. Just try it and give it a try and see where you go. And then the denominator, we've got 2 times 3 is 6. So we're left with 2 plus or minus 10 over 6. Our discriminant came out as a perfect square greater than 0. So we know that we're going to get two rational solutions. So it says solve giving exact solutions n to the nearest 10th if necessary. So we go x is equal to negative 2 plus 10 over 6, which is 8 over 6, which simplifies to 4/3. And if I was to plug that into a calculator to the nearest 10th, I would get 1.3. Sometimes I'll put this little dot over my equal sign because that means it's approximately equal. It's a way of showing that you have rounded. My next solution would be negative 2 minus 10 divided by 6, which is negative 12 divided by 6, which is negative 2. And that one's not necessary to answer to the nearest 10th. All right. Last one. Oh, and that is a hint that this one was factorable. So if you didn't want to use the quadratic formula, if it didn't tell you have to, then you were welcome to solve this one using the quadratic formula. Or sorry, using factoring. Last one, I'm tricking you. It's not equal to 0, so make sure you do that first. 2x squared minus 4x minus 7 equals 0. My A is 2, my B is negative 4, and my C is negative 7. I'm using the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Then I'm plugging in. So like I said, sometimes I just draw the brackets, and then I can fill in for them after so that I can see where I'm plugging in. All right, so my b value is negative 4. That's going in where the b is. My A value is 2, that's going where the A is, and my C value is negative 7. Plugging this into my calculator, and I've got 4 plus or minus. Okay, so So looking at my calculator, -4 squared. Make sure your calculator puts brackets around it. Make sure it comes out as positive 16. Now I'm going to look ahead and see two negatives. So I'm going to put plus 4 times 2 times 7. If you're not afraid of using the negative button on your calculator, put -4 times 2 times -7. Totally up to you. But we get 72. All over 2 times 2, which is 4. Practice simplifying this. This would be a great place to go to your decimal answers. X equals 4 plus root 72 divided by 4, which should give you 3.1, and 4 minus root 72 all divided by 4, which gives you -1.1. To simplify and give exact solutions, you have to simplify your radical. So I'm going to simplify root 72 over here. It's root 36 times root 2, which gives me 6 root 2. So I'm going to plug in here 6 root 2 divided by 4. So you can either divide both terms by 4, or you can look to see what is a common factor, and I can pull out a 2. So if I greatest common factor out a 2 from the top, I'm left with 2 plus or minus 3 root 2 all over, and I can greatest common factor out a 2 from the bottom as well if I want, or I can factor 4. Then I can simplify, because these are now factors, I can simplify the 2's. And I'm left with 2 plus or minus 3 root 2 all over 2. Do not try canceling out these 2's. Please, please, please don't cancel out those 2's, right? Because if you do that, then you're not dividing the 3 root 2 divided by 2, right? They both have to get divided by 2. You can't just take it out of 1. This is fully simplified. And if I plugged this into my calculator, 2 plus 3 times root 2 all divided by 2, and 2 minus 3 times root 2 all divided by 2, I would get these two answers as well. And again, these are my approximate solutions because I had to round, and this is my exact solution because I didn't have to do any rounding. All right, good luck with the quadratic formula. You got this.